Hey there, and welcome to another explainer. Look, if you deal with business data at all, you already know the deal. Raw numbers, they're basically useless until they actually tell a story, right? So today we're cutting through all that noise. We're going to review the ultimate analytical toolkit, the measures of central tendency.
Here's the roadmap for this explainer. We'll kick things off by looking at the actual need for central tendency, and then we'll break down the 3 data series. From there, we'll master the mean, median, and mode. And finally, we'll wrap up by troubleshooting some inaccurate data and unlocking the ultimate statistical cheat code. Sounds good? Let's get right into it.
Okay, Section 1. The need for central tendency, from chaos to clarity.
Imagine, just for a second, looking at a massive spreadsheet. You've got the hourly wages of 2,000 factory workers, or maybe the daily active user logs for a massive global app. Suddenly your boss walks in and asks, "So, how are we doing?" Well, you can't exactly read off 2,000 individual numbers, can you? The real question is, how do you take all of that chaotic, raw data and summarize it into just one single, meaningful metric that actually tells a clear story?
Well, the answer is central tendency. Think of it as a single, central value that represents your entire data set. It basically gives us the absolute average, or the middle ground. It takes all that chaos and condenses it right down into one single representative anchor. And honestly, why does this matter? Well, making $1 million decision requires a baseline. Without knowing the absolute middle ground of your data, you are literally flying blind.
Moving on to Section 2, the 3 data series, categorizing the chaos.
So, whenever you're staring down a statistics problem, the very first thing you gotta do is identify this series. It's step 1. First up, we've got the individual series. This is literally just raw data, which we refer to as X. Picture a simple list of individual daily sales transactions, like $65, $70, $80. There are no repetitions listed, just the raw numbers themselves. But then, things evolve into the discrete series. Now, we don't just have the data X, we also introduce frequency, or F. This tells us exactly how many times that specific data point popped up. So, for example, say the transaction value is $40 and the frequency is 5. That just means exactly 5 separate transactions were for $40. Simple enough, right?
Then we have the third type, which takes things a step further. This is the continuous series. Here, we're grouping data into intervals, think 0 to 10, 10 to 20, and so on, alongside their frequency. Basically, the rule of thumb is, if you see an interval, boom, you are instantly working with a continuous series. Figuring out your series, whether it's individual, discrete, or continuous, is absolutely crucial. It's mandatory because it dictates exactly which mathematical formula you're going to need to pull from your toolkit.
All right, Section 3, mastering arithmetic mean, the average playbook.
Now, when you're calculating the arithmetic mean, you've generally got 3 routes you can take, especially when dealing with a continuous series. First, there's the direct method. This is your straightforward multiply and divide calculation. Pretty standard. But if your numbers are just massive, doing that gets super tedious and it's really easy to make a mistake. That is exactly where the shortcut method comes in handy. It uses something called an assumed mean, which we denote as A. You essentially just pick a logical center point to simplify the math. And finally, we have the step deviation method. This one takes that shortcut method but divides your deviations by the class interval, or I. What that does is shrink those massive clunky numbers down into single digits like -1, 0, and 1. It is a total lifesaver. It takes complex modeling and turns it right into simple arithmetic.
And hey, here's a massive pro tip for you. If you know the formula, the table builds itself. Seriously, once you recognize your series and pick your method, just write the formula down first. If your formula calls for the sum of F times D, well, you instantly know your table is going to need a column for F, a column for D, and a column where you multiply those two together. Basically, treat the formula like your architectural blueprint. It tells you exactly what columns you need to map out.
Next step, Section 4, finding median and mode, the center and the popular.
Okay, we found the average, so let's shift gears and locate the exact center of our data, the median. The median is literally the exact middle value of your data set, but, and this is a really critical pitfall, so pay attention, you cannot, I repeat, cannot just pick the middle number out of raw, unorganized data. The mandatory first step is that you absolutely have to arrange your data in ascending or descending order. If you don't sort it first, your median is going to be completely useless.
Now, for a continuous series, finding the median actually feels a lot like a logical progression. Step 1, just calculate n divided by 2, n being the total frequency.
This tells you exactly where that median item lives. Step 2, glance over at your cumulative frequency column, which by the way is really just a running total of your frequencies, and find the value that is just greater than your n over 2 result. That right there locks in your median class interval. And step 3, you just plug that interval's lower limit, the frequency, and the cumulative frequency into the continuous series formula. Step by step, it practically solves itself. Believe it or not, this is exactly the process real analysts use to find median housing prices without some crazy outlier mansion ruining the metric.
Then we have the mode. Honestly, this one is pretty intuitive. It's simply the value that appears most frequently in your dataset, the most popular item. Think of it this way. If the mean is the diplomat trying to please everyone, the mode is basically just winning a popularity contest. In an individual or a simple discrete series, you can usually spot the mode instantly, just by eyeballing the highest frequency.
But hold on. What if you have a tie? Or what if the highest frequency is surrounded by a bunch of other really high numbers? Well, that's when you have to deploy a more advanced tactic called the grouping method. It's kind of the boss level of finding the mode. Instead of just looking for the biggest number, you actually group your frequencies in pairs and add them up. Then you group them in threes and add those up. Finally, you build an analysis table to tally up which class interval won the most groups. It's a foolproof way to reveal the true modal class when the surface-level data is trying to trick you.
Which brings us to Section 5, fixing inaccurate or missing data, the boss level.
Look, human error happens. It's just a fact of life. Let's say you're told a mean was calculated as 50 for 100 items, but then you realize someone accidentally recorded an 80 instead of a 30. Panic mode, right? Nope. When this happens, you absolutely do not need to start from scratch. Here's your exact recovery protocol. First, take that wrong mean and multiply it by the number of items, our good old n, to find the incorrect total sum. Second, just subtract that wrongly recorded value right out of the total. Third, add the correct value back in, and finally, divide that brand new corrected total by n. Boom! Just like that, you've got your new correct mean.
You're also going to run into some pretty confusing data formats out in the wild, like less than or more than cumulative tables. But don't stress, there's a quick hack to fix them. For a less than table, the top frequency stays exactly the same, and you just subtract downwards to find your normal frequencies. For a more than table, the bottom frequency stays the same, and you subtract upwards. That's it. It instantly converts those annoying cumulative tables right back into a normal continuous series table, so you can just apply your standard analytical formulas and move on.
All right, Section 6. The ultimate statistical relationship, the cheat code.
Okay, picture this scenario. You're working on a massive, high-stakes business model. You've managed to isolate the mean and the median, but the mode is just an absolute mess of conflicting data. And your big boardroom meeting? It starts in exactly 5 minutes. How on earth do you find that third measure in time?
Enter the empirical relationship formula. Mode equals 3 times the median minus 2 times the mean. That's it. If you know any two of those values, you can instantly find the third just by using this simple little algebraic equation. It is literally a statistical cheat code, a mathematical rescue that is going to save you an immense amount of time and headache when you're dealing with really complex distributions.
So we've taken chaotic, messy numbers and turned them into structured, actionable insights. But keep this in mind, the math is really only as good as the questions you ask of it. A perfectly calculated mean can still hide a failing business if you completely ignore the median. So with this master toolkit now fully at your disposal, what hidden story in your own real-world data are you going to conquer next? Keep learning, stay curious, and I'll see you in the next explainer.